Hello everyone, my name is Trace Allen and I'm with the Kingman County Humane Society, and thank you so much for clicking on this video. It was a long time coming, alright? Been working on this since we got it. We'll start off with a short little other intro with me, but don't be surprised, it goes somewhere. Thank you so much, grab a deal of popcorn, and see you guys in a little bit. It is currently 1:57 a.m. and I am about to head over to the Humane Society to check on a mama dog. So, thought you'd like to join. Let's head over there. So I've already gotten here, and I've had to come over here and put my keys down because the mother does not like the sound of keys. Let's go check in on her. Also, apologies for my scruffiness, right? You've probably heard that... Okay. As I was saying, before I was so rudely interrupted, was that I'm sorry that I'm so scruffy right now. It's been a very busy week, if you haven't heard. We got 19 new dogs. A lot of these dogs that came in are blind. They have special needs. Some of them have been extreme neglect cases. And that actually happens to be one of our mamas here. Her name's Cookie. She gets very anxious, but let me tell you what, she really loves Rachel Ray, of all things. She decided that when she was rescued, she wanted to be rescued in high class, so when she first got here, one of the only things we could get her to eat was Rachel Ray, and you know what, as long as she's eating. So those videos were recorded a little over 2 months ago. That's where Cookie started at. She was extremely anxious, barking at everyone that came into the room. She only ate one type of food for a very long time, and you have to say I was kind of scared for her. And that's why I really went there as many times as I did, including in the middle of the night, to make sure she was fine. She had 3 puppies, she was blind. It was hard to tell if she was going to take care of them because she had 3 puppies with her, but 3 puppies we had to take away just because she wasn't able to take care of all 6 initially. So those 3 had to be bottle fed for a while Cookie took on the other 3, because when all were taken away, she freaked out because that was her only comfort from her life before. And it took a little bit of getting used to, but Cookie is now probably one of my favorite dogs I've ever gotten to work with. And you may be wondering, well, what's up with Cookie? Why is she blind? Why does her legs, look like that when she stands? And that's what we're going to get into. So if you came over from Facebook, there was a shortened video of this one that kind of just detailed, this is what she used to be like, this is what she's like now. And this is the bigger course. You took 101, now get ready for 202, because we're getting into genetics. Strap in, because it's going to be a long one. To help explain what is going on in Cookie's genes, I'll have to take you back in time to high school biology class. When a mommy dog and a daddy dog love each other very much, they can choose to have puppies. And when they do, their genes are split and recombine. Well, that's a simple way to put it. Dogs have 39 pairs of chromosomes that carry all of the genes of a dog. That's a lot compared to humans, who only have 23 pairs. Anyway, all of these traits can be passed down in weird and complex ways when puppies, or any baby, is brought into the world. But don't worry, we're not getting too deep into that. Like I said, this is only high school bio. To learn more about the passage of genetics, let's look at Gregor Mendel, the father of modern genetics. Mendel is considered the father of modern genetics because it was through his studies of pea plants that we learned that genetics weren't as easy as we thought they were. Instead, genetics can be carried on through many generations without even showing up, but then magically appear. In that case, let's take a look at what Cookie's genes can tell us. So, Cookie is part white German Shepherd, and that coloring of hair in that breed is recessive. This means Cookie's genes would be denoted like this. And if she wasn't white, her genes would be denoted like this. I'm using S here to signify the standard hair trait and W to denote the white hair trait, and we use 2 letters because chromosomes always come in pairs. However, Cookie's genes, if she is not white, could also look like this, meaning she is carrying the white hair gene, but she's not displaying it. That's what we call a recessive trait. Now, this is a Punnett square, and it's an easy way to show how recessive traits are passed through litter to litter. Let's say our little white-haired Cookie had puppies. No, not the ones she had before. This is a new set. And she had them with a standard German Shepherd that was not carrying the gene for white hair at all. Their traits would be passed down like this. All of the puppies would be carriers of the gene, but none of them would actually have white hair. Now let's say one of those puppies that we just had bred with another white-haired carrier. This means that they are both dogs that don't have white hair, but they're still carrying the gene. Theoretically, half of all the puppies that were born in this litter would come out white, and the other half would be standard hair pups that carry the white hair gene. Okay, I get it. It's very confusing what's going on here when you first get into it. But that is pretty simple on how to explain it, because genes just are complex in nature. It's really fun to look through a litter of puppies and theoretical parents to see how this recessive trait can pass on down the line. But dominant and recessive genes aren't the only kinds. Now, to prevent this from getting overly complicated even more, I'm only going to add one more type of trait passage to this whole entire equation, because it's important to understand the gene inside of Cookie that makes her the way she is. And it's called incomplete dominance. Incomplete dominance is a weird way that traits can pass down. Instead of the simple it's there or it's not there, incomplete dominance means the trait can be there and only partially show itself. If we look back at the Punnett square, incomplete dominance is usually denoted by a smaller letter next to the main one and is passed on in a way similar to what we did earlier with the white hair. In Cookie, this trait is passed along in an incomplete dominant manner in this gene called Col9A3. Col9A3. This is a gene that is mutated in this specific way only through Labradors. Yeah, Cookie is also part Labrador, as well as part white German Shepherd, and also possibly Great Pyrenees. There's a lot going on in her. But Col9A3 is what causes this mutation in Labradors specifically, and only Labradors, as far as we know. And it doesn't only pass through incomplete dominance. According to a 2010 study by O. Goldstein, this trait actually has the ability to pass through recessively and in incomplete dominance. It's because this gene mutation has 2 problems. One has to do with dwarfism inside the dog's muscular structure, and also ocular or eye problems. And the muscular structure part of it is only passed through recessively, meaning that you have to have 2 parents that have the mutation in the Col9A3 gene to get muscle problems. But if only one parent has the mutation in the gene, all of the puppies can have eye problems. And I think that's what we experienced here. Since both of Cookie's chromosomes were mutated, we can denote her chromosomes like this. The C will stand for the name Col9A3, and the small m will stand for mutated. Since it seems that only some of Cookie's puppies had dwarfism, the most likely gene structure of the father looks like this. The little s stands for standard. And when we look at the way the genes are passed, all of the puppies would have eye problems because, remember, the gene only has to be mutated once to display that. But 3/4 of the puppies would have muscular problems because they'd have to have both genes mutated to have that. Well, there you have it. A really long-winded way for me to say that Cookie has a few problems. But it was also really fun to look at genetics and how Cookie, passed down her problems to her children. But she doesn't seem to let those problems get her down. In fact, since the 2 months that we first got her, she's really come into her own. And to tell you more about that, here's future me.
Oh, man. Well, it's currently like almost 2 months later after you see those initial videos. But of course, we couldn't end without an update on our favorite mama dog. Let's go ahead and take a look at her.
Thank you so much for watching. It's been a whole lot of fun diving into genetics with you. And I hope you learned a few things, because I certainly did by reading the study by old Goldstein. If you want to read the full study, it is linked down below. It is a lot of technical jargon, but it is very interesting because you can learn a few more things about genetics and how this gene mutates in Labrador dogs. Also, make sure that you check us out over on Twitter, Facebook, and Instagram. All of the links should be scrolling down at the bottom here or somewhere while I'm finishing up talking, because there's going to be a lot of photos posted there, including some really cute photos of puppies that look like this. Yeah, those are Cookie's puppies. Aren't they adorable? The long-haired one is called Shortbread, and the short-haired one is called Buckeye. I love them. They're such beautiful dogs. Anyway, thank you so much for watching once again, and I hope to see you next time as we talk a whole lot more about the animals at the Kingman County Humane Society. Thank you so much. I'll catch you next time.